Good morning to all. Today's topic is carbonyl compounds preparation. Carbonyl compounds means aldehydes and ketones. Okay. Already we have discussed some methods: direct oxidation of alcohols, and then catalytic dehydrogenation of alcohol, and oxidation of alkenes with ozone, and hydration of alkanes. So this times we will discuss the preparation of carbonyl compounds, hydrolysis of gem dihalides. Aldehydes can be prepared by the alkaline hydrolysis of gem dihalide, in which the two halogen atoms are attached to the terminal carbon atom. The halogen atoms are first replaced by the OH groups, and the unstable glycol splits out of molecule of water to form an aldehyde. First of all, 1,1-dichloroalkane is reacted with the base OH minus. The chloride ion is removed and then obtained in OH minus ions. It form an unstable product. Then it is removed a molecule of water. So H2O is removed. So the product RCH double bond O, and aldehyde is produced. Okay. 1,1-dichloromethane CH3CHCl2 is reacted with the OH minus to form CH3CHOH twice. Then one molecule of water is removed. The product acetaldehyde CH3CHO is obtained with one molecule of water. Then ketones are prepared by the hydrolysis of such gem dihalide, in which the two halogens are attached to any carbon atom other than the terminal carbon atom. So aldehyde preparation, only the halogen atom is obtained on the terminal carbon atom, but in ketone preparation, when the two halogen atom attached to any carbon atom other than the terminal carbon atom. Okay, then the RCCl2R is reacted with the hydroxide ion to the base to form an unstable product. Then it is hydrolysis. One molecule of water is removed to form ketone. Okay. The next reaction, sixth preparation of carbonyl compound is pyrolysis of salt of carboxylic acid. Pyrolysis of salt of carboxylic acid. Aldehyde and ketones can be prepared by then thermal decomposition. Thermal decomposition means pyrolysis. So aldehydes and ketones can be prepared by pyrolysis of suitable calcium salts of carboxylic acids. Aldehydes or ketones can be prepared by the pyrolysis of suitable calcium salts of carboxylic acid. This method is mainly valuable for synthesizing symmetrical ketones. This method is the pyrolysis of salt of carboxylic acid. This method is mainly valuable for synthesizing symmetrical ketones. Okay, symmetrical ketone. First of all, calcium salt of carboxylic acid is heated pyrolysis to form a symmetrical ketone RC or double bond O plus calcium carbonate salt. For example, calcium acetate. The formula is CH3COO twice Ca2 plus. It is heated to form a product acetone CH3 twice CO or CH3 twice C double bond O plus calcium carbonate is obtained. Okay, calcium acetate pyrolysis the calcium acetate to form acetone. Okay, then seventh method is catalytic decomposition of carboxylic acid. Catalytic decomposition of carboxylic acid. The old method is pyrolysis salt of carboxylic acid. Then this method is catalytic decomposition. So a catalyst is used in this reaction. First of all, simple ketones can be prepared in very good yield, that is 90% yield is obtained by passing the vapors of suitable carboxylic acid. So other than formic acid is not used in this method. Other carboxylic acids are used. So ketones can be prepared by passing the vapors of suitable carboxylic acid over the heated oxide of manganese or thorium. The heated oxides are manganese or thorium. Okay. RC double bond OH, RC double bond OH is reacted with the manganese oxide. The catalyst are manganese oxide M1O at the temperature is 300 degrees Celsius to form a ketone RC double bond OR plus carbon dioxide plus water. For example, acetic acid CH3COOH. Two molecules of acetic acid is heated at 300 degrees Celsius to present a catalyst manganese oxide to form acetone CH3 twice CO plus carbon dioxide and water. Okay, this method is catalytic decomposition of carboxylic acid. Then another one method is Stephen's reduction of nitriles. Stephen's reductions of nitriles. It is useful procedure to prepare aldehyde. It is a useful procedure for preparation of aldehyde. Alkane nitriles are first reduced in ether solution. It is the Stephen's reduction of nitriles are very useful procedure for aldehyde. Alkane nitriles are first reduced in ether solution by hydrogen chloride gas and stannous chloride at room temperature. The aldehyde hydrochloride produced is filtered off and subsequently hydrolyzed with warm water. Okay, the Stephen's reductions of nitriles, this alkane nitriles are first reduced in ether solution by hydrogen chloride and stannous chloride. Alkane nitriles, example RC triple bond in alkane nitriles is first reduced in ether solution. Alkane nitriles or C triple bond N plus 2 hydrogen with hydrochloric acid. Okay, reduction. So it is added with the hydrogen and hydrochloric acid. Stannous chloride or hydrogen chloride at room temperature. The aldehyde hydrochloride produced. The aldehyde hydrochloride is produced. It is filtered off and subsequently hydrolyzed with warm water. Okay. Then another one example RC, the aldehyde hydrochloride is formed as a precipitate. Then it is reacted with water. So the hydrolysis to form an aldehyde with ammonium chloride. This method is not applicable in synthesis of ketone. This Stephen's reduction method is not used in synthesis of ketones. It is used in only the preparation of aldehyde. Okay. Then alkane nitriles is reacted with hydrochloric acid and tin chloride. First of all, produce a product aldehyde hydrochloride. It is a precipitation form. The aldehyde hydrochloride is hydrolyzed with water to form an aldehyde with ammonium chloride. Okay. Then ninth preparation, Rosenmund reduction of acid chloride. Okay, Rosenmund reduction of acid chloride. Aldehyde can be prepared by the reduction of acid chloride with the hydrogen gas in the presence of palladium catalyst supported over barium sulfate at 140 degrees Celsius. Okay, Rosenman reduction of acid chloride. Then the aldehydes are prepared by the reduction of acid chloride. So acid chloride is reacted with hydrogen. Reduction means addition of hydrogen. Okay, then acid chloride is reduction with hydrogen in the presence of palladium catalyst Pd or barium sulfate BaSO4. Then it is heated with 140 degrees Celsius. Okay, to form a product aldehyde or C double bond OH plus HCl. Okay, for Rosenman reduction, aldehydes can be prepared by the reduction of acid chloride with the hydrogen gas in the presence of palladium or copper palladium catalyst supported over the barium sulfate solution. Normally, the aldehyde formed would be further reduced to a primary alcohol. Normally, first of all, aldehyde is produced and would be further reduced to a primary alcohol. But this barium sulfate previous the palladium catalyst, which is deactivated so as not to permit the further reduction of the aldehyde product. This is called Rosenman reduction. Okay, then Rosenman reduction naturally or normally aldehydes are formed and then further reduced to form an alcohol, primary alcohol. But in the barium sulfate is present, barium sulfate poisons the palladium catalyst, which is deactivated so as act to permit the further reduction of aldehyde product. So this is called as Rosenman reduction. Formaldehyde cannot be made by this method because formal chloride HCOCl is very unstable at ordinary temperature. So this method is only used for aldehyde preparation. So in this method, normally aldehydes are produced, then it is reduced to form an primary alcohol. But in this case, barium sulfate poisons the palladium catalyst, which is deactivated so as to not permit the further reduction process. Okay, then this method is Rosenman reduction. Then the formaldehyde cannot be made by this method because formal chloride is very unstable at ordinary temperature. Okay. Then last preparation is from Grignard reagent. Aldehyde can be synthesized by the action of Grignard reagent with excess of formic esters. Aldehydes can be synthesized by the action of Grignard reagent with excess of formic ester. Grignard reagent or MgCl is reacted with formic ester. Formic ester means ethyl formate. HC double bond O, CH double bond O, OC2H5, ethyl formate. Grignard reagent is reacted with ethyl formate to form a product aldehyde or C double bond OH plus ClMgO C6H5. Then ketones are obtained by the addition of Grignard reagent to acid chloride and a subsequent acid hydrolysis. So first of all, the addition of Grignard reagent to acid chloride or C double bond O Cl plus R dash MgI gives a intermediate product is obtained. Then it is hydrolysis to give ketone. Okay, so in this video we discuss preparation of aldehydes or ketones. Aldehydes and ketones are carbonyl compounds. Then first method is from Grignard reagents. Then second method is Rosenman reduction of acid chloride. In this method only aldehydes can be prepared. Then Stephen's reduction of nitriles. This method is used to prepare aldehydes but not synthesis for ketones. Then catalytic decomposition of carboxylic acid. So in this method carboxylic acid is reacted with a catalyst manganese oxide then to form a ketone is obtained. Okay. Then this method is pyrolysis of salts of carboxylic acid. Then carboxylic acid, calcium salt of carboxylic acid is heated to form symmetrical ketone is obtained. Then hydrolysis of gem dihalides. Then the aldehydes can be prepared by the hydrolysis, alkaline hydrolysis of gem dihalides, to which two halogen atoms are attached to the terminal carbon atom. Then the halogen atoms are first replaced by the OH group, and this unstable glycol splits out of molecules of water to form an aldehyde. Okay, so these are the preparations of carbonyl compound or aldehyde and ketones. Okay, students, thank you.